Hello, welcome to today's webinar. We are happy to have you with us for this Getting to Zero session, the Buildings Case Study Jam. I'm Connie Umfris, Communications Manager here at New Buildings Institute. Quick acknowledgement of the sponsors you see here. Their support of this webinar series provides ongoing opportunities for knowledge sharing around actionable solutions to drive the highest levels of efficiency in buildings. Want to let you know that you are muted. We cannot hear you. This helps keep the background noise down so everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you're having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. We will take a few questions at the end of the presentation. Please ask questions in the same question pane. Please take a moment to answer the survey at the end of the webinar. We consider your input in the planning of future sessions. If you are seeking AIA credits, the survey is where you will share your AIA number for credit submission. This session is being recorded. All registrants will receive an email tomorrow with links to the recording and slides for the session. If you need a certificate of attendance for your records, it will also be part of tomorrow's follow-up. A little bit about NBI. We've been in the energy efficiency space for almost 25 years, working to protect people and the planet through efficiency solutions. Here is today's panel and the order of speakers. We are grateful to have Matt Welker acting as our moderator for today. Matt, over to you.
Awesome, thanks Connie, and hi all, welcome to today's webinar. We have a great set of panelists and presentations lined up for us to get through. So my name is Matt Welker. I am a member of the 2030 commitment team at the American Institute of Architects. And I'm really excited to again be here with you all today. Again, great set of panelists really getting into the meat of what makes buildings effective. So my initial comments this morning are intended to introduce our program, the 2030 Commitment, and perhaps set the stage for some of the more in-depth case studies that will follow. So to start with, for those of you who may not already know, the AIA 2030 Commitment Program is a voluntary program administered by the AIA as part of our work to build a carbon neutral future. We're committed to getting to zero together and share that value with NBI. The mission of the AIA 2030 Commitment is to support the 2030 Challenge and transform the practice of architecture in a way that's holistic, firm-wide, project-based, and data-driven. We've been at it for about 10 years now, and in that time, the program has grown pretty dramatically from a small number of architecture firms to well over 700 architecture, engineering, consulting, and real estate development companies. We're working to be a resource for the whole design team and move beyond just that architectural start we began with. At this point, many of the largest design and engineering firms have already joined the program, but we continue to welcome new signatories of all sizes every week. Small firms, medium firms, large firms from a variety of disciplines. Got ahead of myself. So the why that we do this is because building operations are responsible for about 30% of greenhouse gas emissions globally. Overall, buildings are responsible for about 40%. And so that 3/4 of the emissions that come from operations are really about controlling energy efficiency and about fuel sources and driving those numbers down to do our part toward that goal. The other 1/4 of emissions come from embodied carbon, which are certainly of increased attention to our members, certainly, and to those practicing and building a better world. And we see this sort of increasing interest in that area. And so the 2030 Commitment, our design data exchange, which is how firm signatories engage and interact with us, are being adapted to better respond to those initial and increasing concerns.
Do you need some help, Matt?
Yes, please.
There you go.
Awesome. And so while the targets definitely get the focus of the attention when we talk about the 2030 Commitment Program, That's not where our vision ends. We remain much broader. We're really interested in how firms and companies are transforming their operations and their workflows to make sure that sustainability and high-performing buildings, energy-efficient buildings, are part of the standard workflow and are being brought to bear on every project. And so that's why we ask firms and companies who engage in our program to take time in their first year of participation to develop a sustainability action plan and set goals for themselves and revise their processes to set them up for success later. So these are the 5 steps that companies go through. The first 2 happen in the first year, the second 2 happen in the second year, and the 5th one happens in the 3rd year of participation. So good news, of course, is that the work can be done. We can achieve net zero energy buildings. And we see this when we look at the program data. So in 2019, which is the most recent data year we have on file, our 2030 signatories reported over 3 billion square feet of over 3 billion square feet of building data around the world. About 2 billion of that was in the US, so a little over 1 billion was outside of the US. And it demonstrates that we can have success, and we're seeing change at a pretty tremendous scale. Similarly, this data set revealed 194 whole building projects that are reported to be net zero energy, so achieving a 100% EUI reduction or greater. And that's what you're seeing on this map, is those projects in the United States that are currently on track to be zero net energy. The color code represents different use types. And so you're seeing, again, that diversity where we're seeing that there are examples and case studies and real projects across the country at increasing numbers that are set up to achieve the targets that we're talking about today. Overall, the building contributions that we see from our program members equated to saving 20.2 million metric tons of CO2. That's the same as removing 4.4 million cars from the road or sequestering the carbon that you would get in 26.4 million acres of forest. So really substantial impacts we have when we work together and collectively to bring to bear the sort of examples and best practices that we're going to dive more deeply into in these case studies, and we bring them to bear on every project that we work on. I'm going to save a lot of the tidbits and sort of best practices for our presenters to dive more deeply into, but it's really important to understand that design strategies do have a great impact on building energy use. And by tackling passive strategies in particular, we can achieve really radical savings that drive us toward our high efficiency buildings. So we did recently a 3-part webinar series focusing on the secrets to success that different companies who are participating in the 2030 commitment took to meet the portfolio challenge overall. Last year, only 27 firms met the challenge, so a relatively small percentage. But of those, there are some common threads, and again, we'll hear those today because they're the secrets to high-performing projects become the secrets to high-performing firms. One of those is passive design strategy. So when we did this 3-part webinar, over and over again, they said, we're investing in passive design strategies. We're investing in Passive House. We're pursuing certification. We're bringing it to bear on our projects. And from residential to commercial, we're seeing savings upwards of 80% that are delivering additional value to our clients. We're seeing more resilient buildings that can withstand power outages or changing climate. We're also seeing beautiful buildings or quiet buildings, or there are a number of those sort of factors that go in when we focus on our insulation, our orientation, and our enclosure. So really dramatic savings that we're delivering to our clients by focusing first on our passive design strategies. The second sort of thread, and you'll hear elements of this in the subsequent presentations, are around modeling. Energy modeling for projects is a really core pathway to having high performing buildings and really essential to making sure that we're getting net zero buildings, net zero energy buildings. We need to know what are the design decisions and when are those being made that are affecting and driving down the energy consumption in our buildings to transform them in a really meaningful way. It's the best way at getting at real energy use intensity, but also cost savings to the client. So somebody who's not modeling is leaving significant dollars on the table for their clients. And that can be translated into the things that motivate clients, right? So we'll, I think, again, hear nuggets of this and how each of these presenters were working with their clients to drive them toward net zero energy buildings. But one thing I recently heard from talking to a 2030 signatory was they're saying, hey, I work on K-12 spaces, and so I take my prospective savings on energy efficiency and I turn that into teacher salaries, because that's what motivates my client. When they can think about the operational savings that we'll achieve by investing more upfront now in these design decisions, in some cases, and in some cases not even more, that means there's more money for teacher salaries or benefits or food programs or sort of whatever that motivating factor is. It becomes a really compelling way to drive change and encourage them to perhaps go further as clients than they were initially prepared to go. The other piece on energy modeling is that regardless of who's doing it, we're finding that when projects are energy modeled, they're achieving on average north of 30% greater energy savings than those that aren't, just based within our 2030 data. So again, a sizable imprint. The proliferation of tools at varying price points and sophistication means that there is a tool out for you that can work regardless of your role on the project or when you're coming onto the project. There are a number of tools and resources available that make taking the essential steps of energy modeling for bettering your project more doable than ever. And AIA, as well as MBI and others, have great resources on that. So I'd particularly highlight AIA's Building Performance Simulation for Architects Guide. It's a great resource available on our website that dives into where you can have major impacts at each point during the evolution of the project, as well as some tools to help you. The third thread I want to highlight is around education on renewable energy options and embedding that and building that awareness within project teams and with your clients. I want to highlight this quote from Julie Hiramoto. She is an architect at HKS and a past chair of our Committee on the Environment. This quote is from her testimony to Congress advocating for energy standards in federal buildings, and she says that it is of paramount importance that buildings be built and renovated to consume less energy, and wherever possible, buildings should produce clean energy to be put back in the grid. So certainly that's true as we think about zero net energy buildings, but also about the opportunity of our buildings to support our infrastructure and maintain operations. To that end, AIA just this week released a primer for architects, but equally relevant for many project team members on basics of renewable energy, both on-site and off-site. So different options, how to apply them, when to pick one versus another, opportunities to consider it, and what some of those savings could be. So it's a really great starting resource for teams that are just beginning that process of beginning education and awareness internally about what those options are to make their buildings not only more efficient, but also producing clean energy and returning that back to the grid. So those are just a few tastes. You'll hear themes of those throughout the presentations from our excellent speakers. They're going to go into more depth and detail, really great nuggets that you can take away and apply to your own projects. So I'm excited to get into those. First up, we'll have Dan Luddy from PAE Consulting Engineers talking about one of his projects. We're going to control pass over to him. While you do that, if you have questions about the 2030 commitment, certainly reach out to me, and then be sure to be adding your questions for the presenters into the chat box, and we'll get through those at the end of the presentations. So Dan?
Yes. Thanks,
Awesome.
Matt. All right, I think I have control and we're good to go. So let me be the first to jump right into it. Again, my name is Dan Luddy. I am with PAE, which is a consulting engineering firm that does mechanical, electrical, plumbing, lighting, technology, and also I'm part of the building analysis and modeling group. So today we're going to talk about our Terwilliger Plaza project, which is in Portland, Oregon. Let me see if I can change the slides here. Okay. Right, so this project is a 10-story high-rise senior living facility just south of downtown in Portland, Oregon. It is about 250,000 square feet of conditioned area, and the most prominent sustainability targets that we established, which we'll talk more about, is targeting BS Plus 2018 Passive House certification for the building. And so this project is exciting to us for a number of reasons. Originally the owner came to us with sort of an intent to they just wanted a sustainable building. They have many stakeholders. There's a community board that from the residents that dictates what the program should be like and what they want to see in the building. Let me see if I'm having some trouble selecting this next slide. There we go. Okay. They have very specific requirements in terms of the building programming and the expectations. These are meant to be luxury apartments with full amenities. There's going to be a movie theater in the building. There's rooftop amenity spaces with a lounge and other sorts of things that the occupants want. There's high expectations in terms of the performance of the building, thermal comfort, indoor air quality, lighting levels for this senior population that will be inhabiting it. And they just want to provide a space that has everything that they need. And they were not willing to sacrifice anything in terms of creature comforts for sustainability necessarily in the beginning. So the first part of the discussion was, okay, you say you want some level of sustainability, but what does that mean? And what sort of targets are reasonable for this type of building and what you are looking for? So as we'll find, there was a lot of work that was done with early energy and water analysis to see what's sort of capable with this sort of program. And we explored a number of different potential certifications for this building to be able to not only put a plaque on the door, but also have some sort of meaningful impact on the way that the project is built and to be able to hold them to a standard. And as a result, we were able to, through these discussions early, get buy-in from all the team members, ownership, and also the design team, including architecture and all the consultants. So the overview in terms of the sustainability targets that we came up with that everyone got excited about was, first of all, Passive House, which this is just a quick primer on the idea, which is to emphasize the passive elements of your building and then reduce the size of your active heating and cooling. So when we're looking at the building itself, that means super insulation, tight air sealing, minimizing heating and cooling loads, and on the mechanical side, having continuous filtered ventilation with heat recovery. In addition to that target, the building also was signed up to eliminate fossil fuels altogether, to have an all-electric building, which means that we, over time, as the grid gets cleaner, then we are also reducing our carbon emissions and riding that wave. And the team also wanted to target the Architecture 2030 energy target for this type of building, which is an EUI of 10, which is quite an aggressive goal for a dense, high-rise multifamily building. And I will say that the owner, after establishing these, the biggest champion on the project for these goals ended up being the owner, that they were the most excited about being able to commit to these. This will be potentially the largest passive house multifamily project on the West Coast when it's completed. And they're holding our feet to the fire when it comes to making sure that this is managed properly and that we are delivering on those goals. Okay, a little bit about how we are able to achieve those goals is the sort of analysis that we're doing to provide feedback as the design process is going, and we can talk a little bit about the lessons learned through that. There's two main types of analysis that kept coming up through the design process to help keep the team on track and to make sure that they were meeting their targets. So one is doing energy modeling at specific intervals from SD onwards. So this was first to establish the targets that we need for passive house certification, but also to be able to look at impacts of different potential energy conservation measures, figure out how we can best balance heating and cooling loads to minimize the need for active heating and cooling to be able to address that. The other analysis that ended up being most critical, I would say, is the 30-year life cycle cost analysis. This was really key in getting past the discussion of first costs and just in expanding that idea into what's going to be the impact over the next 30 years of the lifetime of this building. This the ownership is going to be holding this building for a long time, and they want to make the best decisions for the long term. And being able to look at not only the first cost, but maintenance and the benefits of some of those different technologies and the improvements to the value of these units that will be more comfortable and more energy efficient for the tenants really helped us to drive them in the direction of a system that made sense not only in terms of energy efficiency, but also overall operating costs for them. This is just a quick overview of some of the different EEMs that we looked at without specific description, but just to say that we looked at a number of different options with them. All right, so to dig into some of the details, let's start with the building envelope. And when it comes to Passive House, I find that there's two puns that just elicit groans that are kind of here on this slide. So one is pushing the envelope, and the other one is the devil's in the details, right? So on the left-hand side, we have just a sample of the typical wall construction where compared to a sort of code basic multifamily building, which has insulation between the steel studs, in this case for a high-rise, we added a layer of external insulation that was bridged by the connections for the rain screen, but we plan on using fiberglass clips to be able to attach the rain screen on to minimize the amount of thermal loss that happens in that case. And then in terms of the details, we worked with the architects to really dig into some of the specific thermal bridges that are occurring on the building. There are balconies, there are of course the rain screen connections. There's a lot of different components that are potentially impacting the thermal layer of the envelope. And so we basically reviewed every detail to identify those that are most critical, and then ran different heat transfer analysis, as you can see on the right, to be able to either mitigate or minimize those thermal bridges in most cases. For a building of this size and this overall massing, I will say that the envelope requirements were not as strict as if you think of a sort of passive house approach to, say, a single family house, where there's a lot more envelope area to the internal volume. So we were able to get away with not having to address as many thermal bridges and still be able to deliver those heating and cooling loads that we are required to do. Additionally, windows are a significant driver of envelope performance, so we took a lot of time to evaluate some different window options. They will be using triple pane fiberglass windows for the entire building, and as part of that, there was also a lot of work done into optimizing the shading based on the facade and the different components. There are external shades on many of the windows that will assist in reducing solar heat gain during the brightest hours of the day. We are fortunate that in this location in Portland, there's a large halo that extends behind the building. So we're able to do some site analysis to see what are the most critical areas where we do have to implement that shading. Okay, moving on to some of the system designs. This is a schematic of the basic mechanical system, and the approach here is to separate the ventilation from the heating and cooling. So we have energy recovery ventilators, centralized energy recovery ventilators that provide fresh filtered air to each of the apartments continuously. The exhaust then routes back to those ventilators, and the heat is recovered when needed. Additionally, there is a VRF heat pump system that provides heating and cooling when necessary. We anticipate that the VRF will only need to operate during the most extremes of the summer and the winter, that during much of the swing season, that heating and cooling can just remain off, and that the ventilation load circulating through the space will be able to handle most of the thermal comfort needs of the occupants. Within the space itself, the occupants will have control via thermostats. They will also have ceiling fans to be able to move that air, get that air circulation around, and the spaces will also be equipped with operable windows too. So it is sometimes there's a misconception that passive house means that you have to be completely isolated from outside. That is not the case. You can have operable windows, you can have openings, and so that's what we've incorporated here. next slide, I believe, is yes, the domestic hot water system. So because we've committed to an all-electric building, when it comes to the service hot water for all the apartments, we elected to go with a heat pump system that's located on the roof. Ideally, we'd like to put that in the garage usually when we can, because of less fluctuations in the ambient temperature. That helps the heat pump system. But in this case, they just didn't have the space in the parking garage. So the rooftop it was, and because it has a COP in the range of 3, it means that we're being able to utilize 3 units of energy for every 1 unit of work that goes into it. So it's significantly more efficient than a gas-fired heating system. So that's a lot of the systems sort of behind the scenes when it comes to the appliances that the tenants will have in their space. There's a lot of discussion around the expectations and the need to have sort of high-end appliances for the units. We certainly wanted to go with Energy Star where possible and high efficiency units. Some of the discussions came around the idea of the clothes dryer, and having condensing clothes dryers that are more efficient and also don't need an exhaust duct, and because they're sort of a heat pump technology as well, they are much more efficient. It does mean that the clothes take a bit longer to dry, but the technology has come a long way in the past 5-10 years. And in fact, the owner himself bought a clothes dryer that's a heat pump, a condensing clothes dryer, in order to test it out, and came away saying that he thought it was great, and they're keeping it in their own personal house. So that's an interesting way of approaching it. I've never heard of an owner doing that before. Within the space too, you'll see that there's fireplaces here. There was actually a long discussion about the fireplaces and what we can do besides having a gas fireplace. Ultimately, they decided to delete it altogether and not have a fireplace, and provide different sorts of amenities to the occupant instead. And then moving on to the kitchen, we have induction cooktops for all the spaces, which offer a superior cooking experience to natural gas in many applications. Of course, many of the other appliances are also high efficiency dishwashers, refrigerators, things like that. And then so moving on to, that's talking a lot about the energy efficiency measures that we included in the project, but the renewable energy production as well. So the owner had a big commitment to this and wanted to send a message and have a big impact for their tenants. So the building itself will have a rooftop PV system, about 196 kilowatts, which is very large, and had to be balanced with the other demands of the roof. Excuse me, my voice is a little off. Excuse me. The rooftop system was balanced with a green roof and mechanical constraints. In addition, the adjacent buildings were also, which are also owned by the owner, will have PV as well to help offset for the building. So to quickly wrap up on the project, the EUI target, oops, one slide too many. The EUI target that we're achieving before factoring in the renewable energy is about 18. When you factor in the PV on the other roofs, it's an EUI about 13. So not quite at our goal of the Architecture 2030 target. However, because of the density of this building, being a high rise and the relative small rooftop that we have to work with, we actually find that the energy used per person is about 70 to 80% less than equivalent multifamily buildings. But when you look at it on a square footage metric, we're just under the target. However, I think we're certainly happy with the performance of the overall project and the owners as well. And it means that they have less, it's cheaper and easier for them to purchase offsite renewable energy to offset the remaining usage. And quickly, just want to mention too that the next step that we're looking at is greenhouse gas emissions. Ultimately, it's in our view not about saving kilowatt hours; it's about saving tons of CO2 from the atmosphere. So the next step is looking at the operational emissions associated with the building relative to embodied emissions and some of the other key factors, such as refrigerants, which can have a significant impact on the overall emissions for the project. The key takeaways here, so you can see we're defining the actionable goals early, committing to those, using early energy analysis to be able to drive those decisions and hold the team to those points, getting buy-in from the owner and the design team, getting that enthusiasm up front was really critical in keeping these together, keeping these goals together. and just demonstrating that sustainability can impact or complement other design goals in terms of thermal comfort, in terms of a comfortable space, a quiet space, having fresh filtered air. Those things can all be incorporated into the sustainability goals and technologies that you use in your building as well. And that is it for me.
Awesome, Dan. That was a fantastic presentation to get us started. I think that owner story is a really strong and compelling one, which becomes really important when we think about how we're goal setting and then how you bring them along and they become a champion, right? I love the idea that your owner's taking the dryer, looking for the efficiency there, testing it in their own home and loving it. So it's a great story, and thank you for sharing it. Up next, we have Bill McClay from McClay Architects. Bill, we're passing you controls.
Where do I look?
Bill, you're going to want to click into the window, and in the bottom left, there can be, if you hover over, there are controls.
Do I have control or not?
You sure do.
Okay, great. So I can move forward?
Yes.
Thank you very much. Thank you for the last presentation. That was definitely wonderful to see, and thank you. I'm Bill McClay from McClay Architects. We specialize in net zero buildings. It's pretty much all that our firm does, and we wrote a book on the lower right, The New Net Zero. So this,
Are you having trouble controlling it, Bill?
Yeah, I can't advance.
Can you just go, why don't you just go ahead and let me know when it's time
Sure,
to advance the slide, and I'll take care of it.
That sounds great.
Great.
So this slide, this building is a dining hall in Proctor Academy, completed in 2017. The design work we did was, I think, going back to 2014 and 2015. At that point in time, it was a very real question, could you do a net zero food service, period, or would it be so ridiculously expensive that it would be, nobody would want to do it. So that was what we saw as the 900-pound gorilla. Next. And so this facility does 250 meals 3 times a day and basically all year round. So I mean, it is a heavily used material, dining facility. Next. So McDonald's and fast food and food service. The range in food service is 200 to over 400 kBTUs per square foot per year. Next. If we, the average is 267. Next. If we look at single family homes, typical, all of our work is pretty much in northern climates. So we look at things, single family homes, offices, classrooms that are at 15 to 25 kBTUs per square foot per year. Next. So what was our net zero food service strategy? Next. So we took basically the way we look at a building with process loads, which a kitchen is clearly a process load, not a normal load. We start off looking at what's the base EUI. So that's the 15 to 25 that we do for a single family home or other projects. Then on top of that, next is the food service process loads. That's the big gorilla. And obviously that needs to be reduced as much as possible, but ultimately you add that EUI onto the base EUI, and next, you get the net zero food service EUI total, and then next. Then like any other net zero building, once you've got that, you then power it with renewable energy, in this case, solar. Next. So let's go into the process a little bit. In terms of this project, the hood makeup air is over 40% of the entire load. Cooking comes in second, and then space heating and other loads after that. So it's not a typical building. It has very significant, over 50% or service or process loads. Next. So this, we looked at multiple different ways of doing the building, from net zero to carbon neutral to code compliant. There's three that we sort of looked at in more depth. Option one was code compliant. Option two was, or it's option three, I think, is net zero ready building. And option, I'm sorry, yeah, and option three is a renewable, which was done with wood pellet boiler. If you, in each of these graphs, if you look at the green is with a fixed speed hood. The blue is a variable speed hood, and the yellow is a variable speed hood with heat recovery. At the time, we were able to get it, something from Canada that was at that time UL listed. I'm not sure it's still available anymore. It didn't make a huge increase over just the variable speed, which I think most people know. The fixed is just you turn on one burner and it's going to full volume, and the variable is as you turn on more burners, the speed of the hood goes up, and so that's a pretty good energy conserving structure. So we did end up with the net zero ready and then the net zero building. Next. So what does that look like financially? We normally look to make all of our net zero buildings cash flow positive from day one. We weren't quite able to do that on this project. The upper green line is the net zero ready and net zero building, and the blue lower one is with a propane boiler. So what you can see is, when you start out, it's significantly more cost for the net zero ready green than it is for the blue. However, in 27 years, there actually is a break-even point, and then you start to, buy down. Obviously, for many clients, that would not be, that may not be acceptable. Proctor Academy has very high environmental aspirations and was very committed to that, and said, yes, we're going to be around here 50 years from now, and it's worth investing in the right system. Next. So, this was also saving a lot of carbon, and that is, the lesson is that they were really committed to doing that. Next. So, what are some of the key pieces? So first, this is a private boarding school. Burgers and fries are really, they're really important and critical. So how are you going to do that without fossil fuels? Well, it turns out there's what to me seems like a magic device called the combi oven, which actually can make fries and burgers and do all kinds of other cooking that is actually healthier and better tasting than doing it with gas. We hired a special consultant on the net zero energy kitchen to look at that and to look at other parts, as was mentioned, induction cooking. Next. So as I mentioned, we reduced the ventilation loads by variable rate. We on ground source heat pumps is basically a whole field that runs the building, because the makeup air, an air source heat pump, which we have often used, can't keep up with the loads, and so therefore you've got to have ground source and buffer tanks, and it is definitely an expensive and elaborate and complicated system. Next. Yeah, so the ground source heat pumps ventilation. Next. So there was solar. You can see there's a small amount of solar on the roof, but on the campus they have a larger solar system. So it is very near net zero. Next. Next, yeah. The most critical part, however, of the whole building process is educating users. I mean, right at the beginning, this was a school like any other school, which had all gas appliances. That's what they were used to. They were open to looking at an all-electric kitchen, but there wasn't lots of enthusiasm at the beginning. So our consultant went with them to facilities that had all-electric kitchens and walked through all of that so that they had full buy-in. It wasn't just the administration saying you're going to have an all-electric kitchen. It was the people who were using it said, yeah, we're willing to try that, and it looks like this should be good. Then after that, the most critical part obviously was as they first moved into the building, really giving support so that they knew how to properly use the equipment. With that, the staff working in the kitchen, the students, the administration, all of the school are incredibly pleased with improved quality of food and also doing it renewably. Next. So what did Procter get to for their EUI? It got to 85, which is, you know, still a lot less than the 260 that's than the average. Next. And in that EUI, there's a pizza oven, which is 5 of the EUI, and it they did not want wood, they wanted it gas, and you know that was one menu item that had to violate, otherwise it would have been a 100% net zero building. Next. So I'd like to leave you with, this is the interior of the kitchen. You can see the combi ovens and all of the other electric devices. This is totally achievable today. Next. It's affordable, affordable for them. I mean, it's not the least cost option, but it's within the realm of reality. It's not something that, you know, somebody's going to laugh at saying you spent so much money to do this. Next. It's the healthiest food that they've produced. It's healthy for staff, it's healthy for students and people being in the building. Next. And we hope it's a beautiful building and a beautiful experience for students and staff and guests to be there. Next. And so with that, I'm done. This is a copy of a photo of our book, The New Net Zero, which goes into these and other detail. Actually, I'm not sure if Procter's in that, but we have a lot of similar projects in the book, and a lot of them are commercial and institutional.
Great, Bill. Thank you for that presentation. It's great to see how you're honing in on a few really key, really smart decisions and using that to sort of unlock both energy savings and long-term dollar savings, but also like unlocking healthier food options, right? It goes back to what we heard in Dan's presentation about some of the sort of ultimate co-benefits we can find when we're using sustainability as a lever to make other decisions. So that's really exciting. So thank you again for your presentation. Next up, we have Roger Chang from DLR Group.
Hi, and thank you for having me on this webinar. And I'm really excited to build upon the story that Bill shared with another net zero energy dining journey. This is a project at Swarthmore College, a liberal arts college between Wilmington, Delaware, and Philadelphia, Pennsylvania, a project we started in 2018. Swarthmore College has approximately 1,600 students on a beautiful 425-acre Arboretum campus. Around the time that we were awarded this project, they started to develop a roadmap to zero energy to achieve carbon neutrality by the year 2035. This particular project creates a new dining hall and a renovated student commons. Their current dining hall, Sharples Hall, that you see on the bottom, had grown obsolete with not enough capacity to handle the student population. This is a college that has actually not had a student center since the 1980s, when the last was actually decimated by a fire. One of the key things that you've heard to date is really how important engagement is. Part of our process was to interview over 500 students on campus and really hear from their own voice and words what was important for a successful facility. And what we see on this next slide is just a range of all the different types of workshops we were able to hold with different user groups. And this piece is quite critical for us to listen, but also to educate at the same time. And what we heard out of this were goals and values within these four overarching themes of modern dining, community, sustainability, and functionality. You can see energy is not necessarily a word here, but it's imbued within the sustainability goals and something to balance across all of these drivers. One of the things we really enjoyed exploring was the intersection of food wellness and sustainability, not only at the building scale, but looking upwards at the campus and its regional context, as well as down to the ingredient level. We were really entranced by the concept of a zero footprint, not just a carbon footprint, but recognizing that the types of ingredients you use, where they're harvested from, how they're prepared and cooked, and the food waste that's generated all has a certain footprint. And so we want to address all of these as part of this project. Not only is it about a building, but also about creating a new culture of how food is prepared and served. One thing we know is that many net zero energy buildings incorporate incredible technological innovations, but because of this context that we're working in, it is really important that this building be beautiful and inspiring. So biophilic design was a major driver that was integrated into the mindset of our work. This is a site plan showing existing Sharples Hall in the north and the new dining hall in the south. This is approximately a 90,000 square foot facility with about 10,000 dedicated to a geothermal central plant in the basement of the new dining hall. That geothermal plant will eventually serve the majority of campus and help with their decarbonization goals. We'll start with the first floor plan and just looking at a highlight of Sharples Hall, which will have dining program, a market cafe, a student commons, and places for student organizations. When we go to the new addition, we have a large main dining hall space across 2 floors with platform type servery stations so that students for the first time can actually see how their food is being prepped directly in front of them. And the back of the house area is quite compact in nature, but will serve as a central hub for a lot of material transfer to the campus. So when we look at net zero energy, our approach is looking at this in 2 ways. From the top down, looking at benchmarking from projects that Bill shared, other similar types of facilities with food service components, looking at renewable energy potential, but also then from the bottom up based on the SPACE program. I'd say that the most important thing was to be able to take the insights we gained from the workshops to really right-size the program. We started out with actually a much larger building, and we're able to really refine this and fine tune it to build just the right amount to respect actually the context that we're working into. Solar rooftop design is really important, especially for a building that doesn't have a flat roof and has a lot of visibility. Many of the massing studies we explored showed a wide range of particular and potential PV capacity. One of the things that we really enjoyed working with on this particular project was a carbon shadow price, recognizing the societal value of carbon. In this particular case, we use a $50 per metric ton value to shape and form part of our life cycle cost analysis. We know that utility rates are still relatively low in the United States, and this essentially doubles the value of avoided emissions. It helps us to drive towards good energy conservation measure features. In this particular case, control of air associated with the commercial kitchen by far has a significant and most significant impact. One of the things we explored and incorporated was a radiant floor system for cooling and heating to really jive well with our focus on indoor environmental quality, thermal comfort, and acoustics. This was a major point in discussion, creating an environment that also supported the overall architectural design goals of the project. One of the other major focuses was on the commercial kitchen, looking at the hundreds of pieces of equipment and technology that allows us to still prepare a wide range of types of food, but in a electrified way. We studied carefully electric demand profiles for each area of the production kitchen and servery areas, as well as the exhaust airflow systems that can highly modulate with newer technologies in response to exactly what is being prepared at a particular station. This is a fairly high capacity building with over 500,000 meals expected per academic year. We ended up setting a target of 1.2 kilowatt hours per meal prepared, about a 60% reduction from the college's existing facility. And this rolled up to an energy use intensity just under 85, very similar to the Proctor School that Bill shared, with about 50% of that to base building energy use and the rest associated with food service, refrigeration, and domestic hot water. So I'll just end with a few renderings of the project, looking at the new addition on the left and the renovated Sharples Hall on the right. Next, a view of the south elevation with the plinth being that featured geothermal central plant basement. Then we move into the primary dining hall space. This is a mass timber structure, cross-laminated timber type. And then moving upwards to the second floor of the dining hall. All of this is really framed by incredible views out to the surrounding arboretum. And here is a cutaway view just of the facility, highlighting some of the features that I've covered. And it's really not just about the contribution of any individual item, but how they all interact in a synergistic way with each other. This project has been under construction since last fall. This is a photo from a couple months ago with the foundation work well underway. Here's another view looking in the other direction. And then finally, a completed aerial rendering. So our journey continues from when we started in 2018 and will continue through 2025. The new addition will be finished in the summer of next year, and then Sharples Hall will be renovated for about a year. This is a project pursuing a Living Building Challenge PETAL certification. So really appreciate your time and exploring and sharing this journey with us today.
Awesome, Roger. Another great presentation. Neat thinking about how this is fitting into sort of multiple ecosystems and that like puzzle energy that you have, right? Fitting into the net zero campus goals, fitting into the food waste system, fitting into sort of the sequence of campus life, and then ultimately how all of the systems and decisions work together synergetically. Another really great presentation. So next up, we have Tracy Stewart from CMTA, and she'll be our final presentation of the day. So if you have questions, be sure to drop those in the question pane and we'll get to them at the end of her presentation. You're up, Tracy.
All righty. Oh, I got it. I got control. Okay. There we go. Okay, so my name is Tracy Stewart. I'm a partner at CMTA, and we're really passionate about the building sciences as a whole. And 10 years ago, I commissioned the first zero energy school, K-12 in the nation. And my current role is leading zero energy and high performance projects across the country. I did spend my first 18 years in the building automation and the controls contracting world. And so today we're going to talk a little bit about zero energy, building automation, commissioning dashboards, and in the framework of a project, NeoCity Academy in outside of Orlando, Florida, Osceola County Schools. So first off, I like to always talk about the why. You know, if you start to look at the cost for schools associated with energy, Florida schools spend over $530 million a year on energy, second only to teachers. So if we look at these operating costs and we look at Osceola County Schools, and we know our client is passionate about reducing operating costs and freeing up dollars. And so if you could just get that at half, really half is a very realistic, achievable, financeable goal. So, you know, what would we do if we could free up $6 million just for that one school district? And if you want to, you can throw a few comments in the chat on what you think we could do in our education system with freeing up that kind of funding. So I did want to, we've talked a lot today about energy use intensity, EUI, and I just want to make sure everybody that's listening to this, because I know there's a lot of newer people out there too, understand what that metric is. And so energy use intensity is the KBTU, so the energy that is consumed by fans and heating and air and lighting and plug loads all converted from kWh or from therms into a kBTU. You divide it by the square foot of the building for 1 year of data. And that's our EUI, or energy use intensity. And so our goal and our philosophy is you get that EUI as low as you possibly can afford, because renewables and solar energy have solar has embodied energy. Embodied carbon, sorry about that. So with that embodied carbon, solar for the sake of solar is not necessarily the most energy efficient or sustainable decision. Conservation, and it may be more cost effective, and it may be more of a sustainable decision. And so whenever we look at projects, we always look at them from the framework of how do we get that EUI down, and then we bring the solar on. Okay, so today our case study is NeoCity Academy, which is the first zero energy school in Florida. And so how we define success for these projects is really one project at a time. And if we look at the typical schools in the country and Osceola County schools, there is 65 EUI. Florida is around 55. Our goal for NeoCity was a 20. So that's really drastic energy reduction from the baselines that we find. And when you get down to a 20, that means now you can afford solar. You can get it on the site. You don't have to go off site. So there's a lot of benefits to that. And one of the key things here is we needed drastic energy reduction, but we were not given any more money or cost per student station than we were allowed to have within a typical project. So like I said earlier, how do we achieve these goals? It's really one project at a time, but it also has to do with one champion at the owner level at a time. When we find a champion who's passionate about zero energy and willing to collaborate and make decisions to go that direction, I really feel that every project we touch could be a zero energy building. So now we're going to jump into the HVAC system. As I said earlier, I spent my time in the controls world and HVAC world, and I'm a mechanical engineer. And so, back in the 70s, we had the energy crisis and VAV systems hit the scene. And what did that do for us? Well, it saved fan power, it saved pumping power, it saved heating and cooling energy. And then, we hit the 90s. Well, I started in the industry in the 90s. And what happened in the 90s? Well, we were able to get building automation systems. And I remember it was like crazy. We could schedule equipment and troubleshoot and control things and do all kinds of things from just sitting at a computer. And then in the late 2000s, we started to see the dedicated outside air systems with energy recovery. And really that was a key component to being able to get that first zero energy school in 2011 that was about a 17 EUI. But as we go into buildings throughout the United States, what do we always see? We always see what we've always seen. We always see the systems and the designs from the 1970s. And so change is difficult. And so that is why changing people's minds to try new things and to think differently is really the biggest battle that we have as a zero energy designer. So really the steps to being zero energy ready or a zero energy building is really make a goal. Then you study everything, you collaborate, you do charrettes, you make decisions that you can cost effectively drive your EUI down. But we're going to focus today on the control systems, the commissioning, and the dashboard, the things that are at the end of the process, because we've already heard a lot about the design process. But the success isn't just in the design. You have to be able to follow it through all the way through operation to get to that goal. So I'm going to talk a little bit about control systems as a whole. So basically a control system is the brains of the heating and air conditioning system in the building. It makes those decisions of, for building comfort, for ventilation, for energy measures. It does all of that. And we need to make sure through the construction process that we get the product that performs the way it was designed. And the first step to that is really the shop drawing review process. That's so critical. I don't think I can tell you one time I've not had to get a revise and resubmit on that, because it's making sure that the contractor fully understands the intent, but also provides documentation to ensure that the owner can maintain the system long-term. Because this is the one thing, if it goes out of whack, is going to have a drastic energy hog on the building. So we also set up meetings early. We discuss with them the design. We try to get them very excited about investing in these projects and the success of them. We discuss the intents and the critical set points and the sequences. And having been a contractor side in the controls world, we also see that collaboration with the contractors to learn from their perspective what is successful, what is not, what they struggle with from maintaining long term, because you don't want a zero energy building that is so complex that it can't maintain its operation long term. And so, you know, we also study the trends. We collaborate with them on how to optimize set points, because we know the #1 cause of failure in a zero energy building is overrides and scheduling changes and things that fall within the building automation system. The next thing is commissioning, and you know, there's a lot that goes into commissioning. I was a commissioning agent. I did not renew my CXA this last time because I don't focus on that as my primary role. But for me, as a zero energy engineer and designer, my #1 thing is functional performance testing. I want to make sure that how things were designed is how they're going to function in the field. And so, you know, if it's tested and the sequences and the operations and the trends are watched and it's operating the way it was designed, then I'm confident that zero energy goal is going to be achieved. You know, there's a lot of, you know, enhanced options you can get in commissioning, and they're nice. But as somebody who tries to get something into an existing budget, an existing student station, I always prefer to spend my money on PV and then let the consulting firm do all their QA, QC stuff in-house. And, you know, with commissioning, the other piece is a lot of times third-party commissioning is, you know, you have a third-party set of eyes on things, but that third-party set of eyes is not necessarily a zero energy expert that always knows how these buildings should perform. And so sometimes we have to go back and also validate things and the operation of things and review the functional testing procedures, because there can be a confusion on the intent for how those things should operate on the commissioning agent side. Another piece is we're seeing a lot more building envelope commissioning, this is, let's see if this video actually works. Okay, fine, it's not working. So as a zero energy consultant, I care about performance metrics, and you know, passing a building pressure test is really the most important component, and really all of the steps, everything else that is done in my eyes for building envelope commissioning is really focused on achieving that goal, a tight envelope. And so the building details, this is actually a 3D mock-up, and so we're starting to do these on our buildings so that we ensure that the sequencing and the construction of the building is going to meet the building pressurization test. And our example is NeoCity, and that building actually failed its building pressure test pretty significantly. It could not hold pressure, and they found out there was an issue with the sequencing of building the wall assembly that put holes in it like Swiss cheese. And so without this building pressure test, you know, we would not have been able to identify that. And, you know, when you look at a mechanical engineer, what's their biggest fear? It's infiltration. When you give a performance metric and you can achieve it, they can design to that. But if you have an envelope that is questionable, and what happens? All your HVAC system gets bigger, it costs more, you have no opportunities to shift cost to other areas. So the next thing is, from an envelope standpoint, advancing. There we go. Thermal imaging. So like I said, performance is what matters. And you know, thermal imaging is a fantastic tool if you do not pass a building pressure test to really find these places for leakage and to address them. So I'm going to show you a little bit about after operation, and you get into Occupy the Building, and this is the cover page of the building automation system. And I'm guessing a lot of you haven't gone into your owner's building automation system and surfed around, but that's something that we do regularly because this is what really defines our success. So here's a cover page, and you see some spots to like click on at the bottom corner. And then you go in and you see, okay, how is this system operating? And you watch it live. And you can go, okay, is the fans running when they shouldn't be running? Is the boiler on? It shouldn't be running. It's a great tool to really troubleshoot and see how things are working. The other piece is you can look at the floor plans and, you know, you have the visual of the space and you say, okay, what's important? Temperature and humidity and CO2. Those are going to want to, you know, those are the things we're looking at for thermal comfort, and we're looking at for indoor air quality. And so a high performance building should not just be about high performing in energy, but also high performing occupants. So if you see something that doesn't look right here, what you do is you go to the next screen and, you know, click on one of those, and then you can look at the systems and go, is something not working properly? And so that you know, building automation system is a key piece of being successful. And the second one that we really use regularly that I absolutely love is the dashboard. Live data is so powerful. We watch consumption, we watch the trends. How are we comparing to the models? It's a tool that's really invaluable that helps us to determine, you know, if we're doing what we need to be doing live. And I think it's really important that it's transparent, because energy models are junk in, junk out. Unless you take those models and you validate them with actual usage, you learn from what you've done in the past and you make them more accurate in the future. And so, you know, we don't want to check a box for LEED or for some sustainability program. As Zero Energy Consulting, your success is really measured in one place. It's at the meter. It's not in the model. All right. And my favorite thing that I always seem to go look at a lot is the sub-meter data. Because when you do an energy model, your energy model breaks things up into categories. And then what you can do is take these categories that were sub-meter and compare them to the model and find out and learn where you're close and where you're not. We found that our plug loads were high, and we're like, what the heck's going on here? Well, the plug loads were high because they were leaving things on 24 hours a day for a while. Someone went out there, they found out, hey, we've been running these things 24 hours a day, you know, and then they fixed it. What's kind of nice is you can see that, you know, weekends, there's one here where you can see where the weekends are, and the usage is low, so we know things are turning off over the weekends. You see things during the day and the night. Are the schedules working properly? It's a fantastic tool. It's available on the internet. You can just go look at it 24 hours a day. It's a fantastic tool to use. But you also have to go to the...
Just
Am I over?
We're running out of time. I don't know if you
Okay.
can wrap this up quick so we can at least answer a couple quick questions today.
Yep, that would be great. This one was just about how you set up your model, and then what you do is you utilize that to compare to the bills. And I can't see the little thing in the corner to advance. Oh, there it is. We also have, you know, dashboards that are from a learning standpoint that are mobile that you can look at. And this is just to click through some pictures. So there's opportunities. So many of us do things from the standpoint of to try to be sustainable in spaces, but we don't share those. So with the dashboards, there's really opportunities to educate people about what's being done in the spaces, why they're being done, and to learn about the systems within the spaces. And I am done. I was about finished. I only had that one really thing left to say, and the rest was flipping away.
Thank you, Tracy. Well, if you guys would like to all turn on your cameras for this quick Q&A, we'll do. Let's see. Okay, so I'm gonna just jump into the first question here. Just to bounce off of Tracy's presentation, all of you deal with commissioning on in some way. So how does commissioning improve the control system design and installation? And has commissioning improved controls in these ZE buildings?
I can jump and grab that one. Absolutely, it has improved it. With commissioning, you're validating what's being installed in the space. Human error is a big problem. And also the other piece of it is in the controls world, they're always pushed back and back, and then there's time allotted to do the work is shrunk and shrunk. A lot of times it falls into commissioning even when buildings are occupied. And so that puts a lot of pressure on those people that are installing all of those programming and all those things in the field. And there's just opportunity for human error in these zero energy buildings, and the commissioning really addresses that.
Anybody else want to contribute?
I would just say that I agree that it's an essential part of any performance for a high performance building. It's just making sure that you're actually getting what you intended to do, and be able to look through and inspect everything. So yeah, it's critical.
Awesome, thank you. When was the contractor integrated into these projects? Pre-design, schematics?
I'm happy to speak to that. I think this is such a key point of success for our project. They were onboarded during concept design, which is pretty rare. It's a CM at risk delivery model, but that way they really help us get to success. So when they see we're having to make trade-offs for an energy feature, they reach out to us and say, "Oh, will this affect our energy goals or some of the other goals that were established early on?" They were very much along for the entire journey, most of it.
Yeah, I would totally agree with that. We frequently do CM projects, or we'll still have a contractor on board at the beginning and then may switch for pre-construction services, because if you're doing something innovative, you want to be doing it with a team of other innovators and people who have been facing those problems, and the contractor is absolutely critical to do that. And where it's been bid, we also will still get the contractor in as soon as we can, and we'll have somebody hired for some pre-construction services so that we're doing things the most cost effectively. And that sort of reinforces, I think, someone else's part, that it's all about the team. If you don't have, the commissioning agent that's done net zero buildings, you're really not getting anywhere.
Okay, anybody else?
We've done it in all different delivery methods, from just general bids all the way through CMs. A lot of times it's just having good networks within the contractor community, and getting input from them as a whole on how to do better design. Any of those different delivery methods work fine, and our opportunities are always there to collaborate.
Yeah, we found it really beneficial, particularly with just doing passive house and detailing, air sealing, and other things that, we can put something on the detail, but just having the people who are actually going to build it in the room, looking at it, reviewing it as we're doing it, so there's no surprises later on that are going to be substantial cost adds, was really helpful and educational to us as well.
Excellent. So we just have a couple more minutes. Matthew, we had somebody ask if that primer is available for free to everybody that you spoke of.
It is. It's free on the AIA website. I'll try to drop a link in the chat if I can. If not, I would encourage you to just Google Architects Primer on Renewable Energy AIA. It should come right up on Google, but it is free for download to anybody, whether you're an AIA member or not.
Excellent. Well, Matthew, I'll add that to our follow-up email as well, so everybody can get that tomorrow when that email comes out. I am going to go ahead and wrap up this Q&A here. I'm sure we could talk for hours, but we have only 2 more minutes. So thank you all. I'm going to do my little plugs here, and we'll have a second to say thank you again. So we do have the Getting to Zero webinars are kind of launched from our Getting to Zero forum, which is happening in October in New York. So save the date. Oops, my controls aren't working. We do have another webinar coming up next month on grid integrated buildings. So join us for that. You can find the link to that at our event page. You can also find links to our the events that we've already had if you go one page deeper into the webinar. So we'll have those links available for you. We have a Getting to Zero resource hub is available to help you on your path to zero. You can check that out at gettingtozeroforum.org. And all of our social media handles there. And these will be very handy next week when we work on Net Zero Buildings Week. We'll be sharing resources. We invite you to join us. You can email me at connie@newbuildings.org, and we have some resources for you to help share your resources and participate in Net Zero Buildings Week. So that is it. Thank you, everybody. I appreciate my panelists today. This is great. And Matthew, thank you so much for moderating. I'm going to go ahead and end the session. Have a great afternoon.
Thank you.
Thank you, everybody.
Thank you.